Okay. On the first one, we're doing the slope. The slope is the change in the y's over the change in the x's. So it's y's over x's. Okay, when you're doing it, to kind of help you, two techniques that'll help you remember how to do it first and prevent you from making mistakes is first, draw this out. Whenever you do it, it'll prevent you from making a very common sign mistake that students make. Okay. Secondly, label your points. That'll also help you prevent a common mistake. Okay. So I would do, it's y2 minus y1. Okay, so it's 12 minus negative 4 and 8 minus negative 2. You could switch which one you're calling point 1 and which one you're calling point 2. It doesn't really matter, okay, which one you call point 1 and which one you call point 2. You'll get to the same answer anyway. Okay. So this would then be 16 over 10, right? Because 12 minus negative 4 is going to be 16. 12 plus 4, which is then 8 over 5. Okay. Number 3, we're going to do it the same way. When I do it, do this. And it's kind of confusing because it's 0, 12, and then 12, 0. So it can be kind of confusing to put it in the right spot. So to prevent you from making some mistakes, doing that would be nice to help you out. Y is on top, X is on the bottom. So y2 minus y1, 12. X2 minus x1. So it's negative 12 over 12, which is negative 1. Okay. You'll notice also when you're reading it, when you're looking at it, you can actually see the points vertically in the problems. 8, 12, a point, right? Negative 2, negative 4, a point. 12, 0, a point. 0, 12, the other point. Vertically, you can actually see the points written down. Let's do 3. Same thing. Start this so you don't make a common sign mistake. X1, Y1, X2, Y2. Negative 10, negative 3, 6, 9. Negative 10, that's negative 10 plus 3, so it's negative 7. 6 minus 9, negative 3, 7, 13. Okay? Any questions? Let's go to the back. This is just talking about slope right now. It's kind of a visual way to do it. What I want you to do is take a look at this and try to do the first 4 right now. Going up except for 4. Right? So it's not just going up. It's more specific than that to determine whether it's a positive line, positive slope. It goes up from left to right. It goes up. But yeah, it does go up. But specifically from left to right, it's going up. That means your answer needs to be positive. You can automatically tell that. Okay? You could do it just using the picture. Rise over run. If you rise 1 and run, that would be run 4. 1/4. It's positive. Rise over run, 1 over 4. Rise 1, run 4, 1 over 4. Or you could use the slope formula and you can label the points if you want. 2 minus 1, 3 minus negative 1, 1 over 4 again. Same deal. Second way is algebraically. The first way is geometrically. Just looking at the picture. Either one's okay. Number 2, you can count it. 1, 2, 3, 4. Negative 4, 1, 2. So you rose negative 4. You're actually going down, so it's negative. So it's negative 4 over 2, running 4. You always run to the right. Or to the right is positive, to the left is negative. Going up is positive, going down is negative. Okay. You could count it a different way. You could count it up here. You go right 2 first, I guess. Down 4, negative 4. Or you could view it differently. Again, you could view it as from this point, start at this point, you could go up 4, which is positive, left 2, which is negative, and you still get 4 over negative 2, which is still the same thing, or namely negative 2 as your slope. You could use the formula. You could do negative 1 minus 3, 1 minus negative 1. You would get negative 4 over 2, which is back to the same thing. Okay. Either way, anyway. You could do it another way, I suppose. Instead of doing negative 1 minus 3, this minus that, you could do 3 minus negative 1 over negative 1 minus 1, 4 over negative 2, which is negative 2, same spot. Lots of different ways. Lots. You could add a new point in there if you feel like. You could say, oh, that's a nice even point, of course. And you could go down 2, right 1. Lots of ways. This is fun, isn't it? Lots of ways to do the same thing. Maybe that's too many ways. Anyways, so number 3, it's vertical. Okay, what's the slope of a vertical line? Do you remember? Did you memorize that? Undefined, yeah. Undefined. If you memorize that and you remember it, slope of a vertical line is undefined. Or if it's drawn in picture and you have 2 points labeled, or you can label 2 points, you can do the slope formula, 4 minus negative 2 over 2 minus 2, which would be 6 over 0. Guess what 6 over 0 is? We don't know. It's undefined. When you divide by 0, it's undefined. Okay, anything over 0 is undefined. Another way to rationalize it is, okay, how much, so if I'm at this point, how much do I rise? I rise 6, you can count 6, and I run left and right 0. 6 over 0 is undefined. Or you could pick a random point way up here, pick at any point. You can rise an infinite amount and go left and right 0. Okay, number 4, what's the slope of a horizontal line? 0. Horizontal. You're not rising anything. So from here, you're not going up anything. You're just going to the right 1, 2, 3, 4. So it's 0 over 4, which is 0. Or you could use the formula. Which will give you 0 over 4, which is back to 0. Does that all make sense? Okay, take out the other piece of paper. 4, 6. Okay. Graphing lines. Okay. Anybody have a suggestion on how to graph this line? Let's just get it graphed. You don't even have to pay attention to the other part of the directions. Just graph the following lines. Or I guess then determine their slope and y-intercept. Whoa, those are all the answers. Yes, sir. Hold on, let me pause it. Okay, so one way was recommended to first graph the y-intercept, which is negative 5. It's negative 5. So first to graph that 1, 2, 3, 4, 5. First graph the y-intercept at negative 5. And then use the slope ratio, rise over run, y's over x's. Okay, to go from the slope, in this case would be 3 over 1. That gives us our directions to go from that y-intercept. We go up 3, 1, 2, 3, right 1. Just in case you wanted to know, that's a pretty darn straight line. Okay. So you could do it that way. Okay. Again, I'm really humble. Next. Oops. What's another way to do it? What's another way to do it? Guys, we can make a table, and that'd be great. Okay. Guess what? Guess which way it works with graphing anything and everything that you ever want to graph. If it's an equation, which one of these things works in absolutely every way? Making a table works for any equation, to graph any equation, no matter what that equation is. You can always graph it using a table. When in doubt, make a table. What do you do with making a table? What do you do? You just draw an XY thing? What do you do from there? Yeah.
You start with like random x points of -2, -1, 0, 1, 2.
Okay, yeah, you can pick random x values. And you can use the equation, because the equation is a rule, how to go from your x's to your y's, or the rule that relates x's and y's. And so you can pick your favorite x's and find the y's that match it, if you want. We're in geometry, right? We're in geometry, not algebra. Okay, algebra would tell you probably have to do like 3, 5 points, something like that. Geometry, in geometry, how many points determine a line? 2. Guess how many points you have to do? 2. Okay, good. So let's just do 2. Or a rule of thumb for graphing with a table is you pick enough x values so that your graph looks pretty. Whatever that means to you. Just make it look pretty. You have to get all the parts of the graph. So if you have x is -2, you can put that for x and find some. Okay. I'm thinking -2 is going to go off the charts. So we probably should pick a different one, right? So we can still make it look pretty. Let's go. So you get -3 minus 5, -8. We might have it on there. I mean, you could keep drawing marks if you want, but anyway, so -2, 1, oh, we did -1, sorry. -1, 1, 2, 3, 4, 5, 6, 7. Okay, at least it's not too far off the charts. Guess where that is? That's on the line we graphed before. It should be if we did it right, because they're all just different points on the line. And then 0 is going to be 0, -5, which happens to be the y-intercept. Okay, connect the dots. You got it. Cool. Just do it again. Start at -5. You can start at -5, and then it's 1/2. 1/2 positive, 1/2, so we go up and to the right. Whenever I'm graphing by slope and an intercept, I recommend you guys to always go to the right and choose to go left, or choose to go up or down. Okay? Always go to the right and choose to go up or down based on the sign of the slope. Okay? Another perfectly straight line. How about in this guy? What should we do? It's different, but we're okay. We're math Jedi, so we can handle it. We're math Jedi. Okay, so why would we put it in solve it for y? We're going to solve it for y. Why would we solve it for y? Well, so that we can put it in slope-intercept form, so that we can see the slope and the y-intercept easily from just looking at it after it's solved. Sure, that's a method. You could do it by table still, even in this form, without solving it for y, or you could do, I suppose you could graph it by the y-intercept and the x-intercept if you wanted, but we're not going to do that today. So we're just going to minus 3x from both sides to solve the equation for y, and we're going to divide by -4. And then look at what we have. Look at this. That's the y-intercept. Start at -3. Our slope is 3/4, so we go up 3, right 4. Oops, wrong spot. 1, 2, 3, 4. And you draw a perfectly straight line. You guys can't do it as good as I can, so you guys need to use a straight edge. But I'm pretty awesome at it, as you can see right now. That's okay. But then if I do this, it's a lot better. Okay, number 4. What the problem is? What is the problem with number 4? Why is it different? What's the deal? There's no y. Okay. So what are you feeling? Okay, if it's x by itself, the slope is not 0. It's actually undefined. Let's solve it for x. Might as well just solve it, because if we solve it for x, then we can actually talk about, then we know what all the x values are on the equation or on the graph. Okay, what that means is x has to be 2 on the graph. All the points on the graph have to have an x value of 2. So put a bunch of points on the graph where the x value is 2. It's pretty much what it says. It's a rule. It says x is 2. So put a bunch of points on the graph where x is 2. What kind of line? Vertical. Those are a bunch of points on the graph where the x is 2. That's what the equation says. That's the only rule, that x has to be 2. You could do it by a table. Okay, so the rule is x has to be 2. It doesn't matter what y is. Those are all on that line. Okay, the rule says x is 2. There's no rule for y. Y can be anything it wants. It has no rule. Life without bounds. Wow. Crazy. Anyways. Okay, guys, if you're having trouble with this tonight, go on to the video and watch the video and listen to the conversation that we just had. Okay?